So this is where we left off in the last video. I just changed the model back to the monkey head, added a new Python file, video 18 simple light, and added two new shader files, video 18 vertex shader and video 18 fragment shader. So we have a rotating textured monkey head. In this video I'm going to do a simple light. So in order to light a model we need the normal vectors. So I'm gonna uncomment these two lines. So now our model just looks like this. We have a giant list of vertices, and after it we have a giant list of vertex textures. And after the textures we have vertex normals. So okay, go back to, I'm gonna delete this and go back to our main program. So now I'm going to add I'm gonna copy the vertex attribute pointer and change this to normals. Positions, textures, normals. So it will be in the location 2. It has 3 values, every normal, object model item size times 3. This is the stride. Change the enable vertex attribute array to 2. And let's calculate the offset for the normals. And I'm going to do it under the texture offset. So normal underscore offset is equal to the I'm gonna do this in parentheses. So texture offset plus the length of object that texture index, length of object that texture index, and times by, let's see, we have in every texture 2 coordinates times the 4 bytes each. So I'm gonna simplify it to 2 times 8, 2 times 4, so 8. So now we have the normal offset calculated. I'm gonna copy this to the normal attribute pointer. Okay, so now we are going to change the vertex shader. So now we have an input layout and the location is equal to 2 and it is a vector free, and how call it vert normals or normal. So vert normal, and I'm going to create an output vector. It is a vector free, let's say frag normal. Frag normal, and in the main I'm going to give frag normal the value of vector for vert normal normal. Okay, so vert normal and 0.0 f dot x, y and z, and this called as whistling. Okay, so now I'm going to the fragment shader. So we have an output vector of frag normal, so we need an input vector of frag normal, input vector free frag normal. Frag normal. Okay, these are okay, and in the main I'm going to define some new variables. So let's say ambient light intensity. Ambient light intensity, and it will be a vector free, and I'm just gonna give it 0.3 f, 0.2 f, and 0.4 f. Okay, another vector free, and it will be the sunlight intensity. Sunlight intensity, and it will be another vector free. Let's say 0.9, 0.9 and 0.9 sunlight intensity, and we need a sunlight direction. Sunlight direction, and it will be another vector free. Sunlight direction, let's say 0.0 on the x and 0.0 on the y, and I'm gonna give it a negative 2.0 on the z. And one last thing, we need to normalize this whole normalize. So normalized vector free. So the next thing, I'm going to create a vector 4. Let's call it texel and give it this value. So Control X and Control V. So sample texture and a new texture. Okay. And the out color. Not the out color, but the vector. I'm gonna define another vector 3 called light intensity. Light intensity. And it will be equal to the ambient light intensity plus the sunlight intensity times the max function or the maximum and the dot product of frag normal and the sunlight direction. It's Control C and Control V. So the dot product of frag normal and sunlight direction, and we cannot have negative light, so we are going to give 0.0 as the second value to the max function. Okay, so now the out color is a vector 4. And we need texel.rgb times the light intensity. Control C, Control V, light intensity, and because it's a vector 4 and this is vector 3 times a vector 3, so we need a fourth value here, and it will be the texel.A or the alpha. Okay. Let's see what we have. So now you can see the individual faces or the polygons of the monkey head. I'm gonna change the light from -2 to 2, so now the monkey's face will be lit. But we have a little problem that the light exists in the model space, so it rotates with the model, so it's always it's somehow bound to his face, so only lit from the front side. So now I'm gonna demonstrate quickly what's happening in my code. So as you see, as the model rotates, the light rotates with it. So it's always lit his front side or his face. And what I wanted to do is this. So as the model rotates, the light stays at one position and always lit that side of the model which is facing to the light. So to solve our problem with the light position, I'm gonna create in the vertex shader another uniform matrix 4, and let's call it light or light position. I'm gonna leave it as light, and I'm gonna multiply this light matrix with this vector 4 light. So the frag normal now becomes the light matrix multiplied by the vector 4 of vert normal, and that's the xyz value because frag normal is a vector free. So that's the vertex, and I'm gonna get the light position, light location, and equal to the, let's copy this line and light. So light location GL uniform blah blah blah, and I'm gonna set the uniform matrix for FV. So just copy this line, paste, and copy the light location, and now it should work. So let's see. Yes, it's working. Now the light is coming from front, where the view is. But after I change the view, not the view, but the light, sunlight direction. So let's change it back to 0 and move it to the negative x to negative 2 on the x. So let's see. So as you see now, the light is coming from the left side, and it's no more rotating with the model. So as you see, the right side of the model is always darker. Let's change this to negative 2. So now it will come, the light will come from the bottom left. So somewhere here is now our light. And one last thing I did, I just went to Blender and exported out the monkey head with smooth shading. So this is the flat shading. This is what we have now, and with the smooth shading turned on, it just hides all those polygons. It looks a bit better. So let's go back and load the monkey, not the JPEG, but the obj monkey underscore smooth. And now it looks beautiful. The light is coming from this direction. So thank you for watching.